Welcome back, chemistry fans. You are looking at a calculator. That's because math is actually starting in chemistry now. So today, what we are going to do is the Unit 1 free response questions. So the idea behind these is to try and get you a little bit more rigor so that you can understand what is expected of you, not only on assessments in my class, but on the AP exam assessment questions, so that you can understand that it's not as easy as it is just in taking notes and working some of the classroom problems. That's just the surface stuff. Okay, so what we're going to do here is we are going to share our screen, and we're going to jump right into these questions. These can be found on Canvas. If you have not located them yet, please do so. Come back to me and we will get started. All right, so question number 1. It is saying that we have 7 different metals and asked to identify which metal it is based on densities. Use the table of densities to identify what the mass of it is. All right, so what we have here is some unknown metal. And then we have volume displacement. What that means is we have some graduated cylinder, has markings on it, and we know what it started out at, 50.40. Then we drop a piece of metal somewhere in here, and the volume then went up to 54.85. So what that means is that the difference between those two numbers, if I subtract them, absolute value them, then we will be able to figure out what the volume is for this metal. So I am going to switch over to my calculator mode here. I'm going to stop sharing. So I've got 54.85 minus 50.40 and a mass of 32.06. All right, so stop sharing and go straight to the big screen here. You are seeing my calculator now. And so 54.85 minus 50.4 will give me 4.45. To the screen here, and then we can do a little bit more calculation. So come back to our screen here, and what I need us to now do is calculate I guess that blue's fine. So density formula is mass over volume. I have a density of 32.0, I'm sorry, I have a mass of 32.06. I have a volume that I just calculated of 4.45. So I'm going to take the division of those two values. Stop my sharing, go back to the other screen here. And so I've got mass of 32.06 divided by 4.45, and what we get is 7.2. So what I need to do now is look upon my chart here of densities and see which one of those is the closest. Well, at 7.20, it's somewhere in between tin and chromium. But chromium is only off by 0.05, tin is off by 0.07. So what we are going to go with then is our correct answer being the chromium. All right, moving onward. Find how to manage this. There we go. Get my bar back. All right, number 2. So darts are thrown at a board. 3 darts land in the bullseye. However, the place was aiming for the triple 20 section, and he hit the wrong place. So yeah, good luck. But the reality is you weren't very accurate. You were very precise, but you were inaccurate. You're not reliable because you didn't hit the place you were aiming for. So in a game of darts, whenever you have to fill in the board, you may actually have lost the game. Now, most of the dart games involve bullseye, but in this case, that's not the case. All right, so number 3. What I'm going to do next is I am going to go to significant figure calculations, calculate the mass. So if you notice in this problem, the way it's set up, I would have grams per milliliter multiplied by milliliter. That means that those milliliters are going to cancel out, leaving me with just the gram unit that I desire for this. So what I'm going to do now is I'm going to multiply those values together. Stop sharing, and I'm going to get my screen here where I'm actually seeing. There it is. And now my values are 16.4 and 1.35. All right, so let's see here what we got. So if I go over here, 16.4 times 1.35, both of these values have 3 significant figures. The 1, the 6, and the 4, 3 significant figures. The 1, the 3, the 5, 3 significant figures. But my answer has 4 significant figures. I can only use 3 of those significant figures. So I am going to now go back to my screen and let's figure that out. Yeah, your answer should only have 3 significant figures, which is what is in the answer. So if I have 16.4 times 1.35, I'm going to get 22.1 grams with the sig figs being gone. So 0.14, I guess I could put this in here and show it to you and then cancel it off and have my correct answer. Okay, now how many centimeters? So this is a metric conversion problem. If I am going 186,000 miles per second, that's a very fast object. How fast that's going to destroy something. But I want it to know how many centimeters in 1 year. So that's what we're going to convert this to. So we have to know a lot of our conversions to do this. So one of them that you can know off the top of your head is that for every 1 year, there are 3,000, for every 1 hour. So 60 seconds times 60 minutes times 24 hours times 365 days will give you 1 year. So if I put that into a calculator here, let's see what that comes up with. So let me shift my screens. So that's 60 seconds. You can't see that. Clear it out. 60 seconds times 60 minutes times 24 hours in a day times 365 days in a year. We got a huge number. Oh my goodness. So let me come back here now and share our screen. Let's write down that conversion. So for every, oh my goodness, what was that value? It was 31536,000. So that's 31,536,000 seconds in 1 year. All right, so we have our first conversion from seconds to years. Quite outstanding. I'm going to erase that portion now so that we can work on the next portion. I'm going to rewrite this up into the air so that it's a little bit out of our way. Seconds per year. So now I have more room to work with. All right, miles to centimeters. I know that for every 1 centimeter, I know that if I have 1 mile, I have 5,280 feet. I know that for every 1 foot, there are 12 inches, and that for every inch, there are 2.54 centimeters. Okay, so I can now, again, start multiplying all of those together to figure out how many centimeters are in a mile. So let me stop sharing, and we'll do the math on that one. So 5,280 feet times 12 inches in a foot times 2.54 centimeters per inch, and I get 160,934. I'm going to have to put that conversion in now. So for every mile, there are, well, here, I'll put it in this terms, 160,934.4 centimeters per mile. Okay, now I have my two conversions. This is the process for dimensional analysis. So I'm going to put this again over here in the corner, 160,934.4 centimeters per mile. And now we're going to utilize all of this to do our dimensional analysis of centimeters per year. So I have 186,000 miles. Well, my conversion that I know for miles to get it into centimeters is for every 1 mile, there is 160,934.4 centimeters. Move this out of the way, sorry. And then for the seconds, there are 315,36000 seconds for every year. So this will put us into our conversion that we are looking for. If I multiply this times this times this, I will get my conversion that I'm looking for. So over here on my calculator, let's stop the sharing here so I can actually do the math here. Writing the stuff down so I can see it whenever. That's one of the flaws of this program here. All right, stop sharing. There's that screen now. So I've got my 160,934.4 in here already. I'm going to multiply that by the starting amount, 186,000 times the number of seconds that are in a year. Or was that, I don't remember what value that one is. Anyway, and there we go. There is the answer, 9.4 times 10 to the 17th. Now, let's take a look at our sig figs, however, though, to make sure that we have this correct. In the first problem, there are 3 sig figs. So I'm going to need to have 3 sig figs, which is what I did place in here. And if you're looking over here in the top of the screen, it's a 0.439. That means that needs to be rounded to the 0.44, which is what my answer is, centimeters per year. So if I'm showing that 9.439 times 10 to the 17, I'm canceling that, rounding it to make it a 4, 9.44 times 10 to the 17 centimeters per year. My horrible handwriting is coming out there. All right. So this is everything that I wish to share with you for the Unit 1 free response questions. The expectation is that you're not just turning in my answers. You are showing your work, and I've hopefully shown you how to work through this, and you are going to be okay with it now. Thank you so much. I will talk with you again soon.